All right. Well, hello, everybody. My name is Tim McKee. It's my pleasure to be here with you today at Sensors Converge. And I'm here to talk to you today about MIPI's I3C Basic. So let's jump right in. So just as an introduction, as many of you I'm sure know, the sensors market is growing between mobiles, IoT, automotive and transportation. We're seeing devices use more and more sensors. Some projections are seeing upwards of 20 sensors in a device. And so in order to meet those demands, we wanted to create I3C as a scalable, cost-effective interface targeting sensors, mobile, IoT, and all of these different areas. So what did we put into I3C? Well, we wanted to simplify connecting and managing multiple sensors in the device. And so it's a multi-drop bus. We reduced the pin count and signal paths. We added support for low power, high speed communication versus the predecessors such as I2C, SPI, and UART. Multi-host arbitration, but all of this still with low complexity, somewhere around 2,000 gates per target, and still maintaining backwards compatibility with legacy I2C devices. So just to kind of get people up to speed on where I3C has been and where we are now. Back in 2016, we released the I3C version 1.0 specification. From there, there was a lot of demand for a license-free version, so we created I3C Basic version 1.0 in 2018. This created a subset of features, but was offered duty-free, license-free. Then back in 2019, we created an updated version of I3C, added some new features, and we were planning to do a basic 1.1 as well, but due to complications, pandemic, all sorts of different things, it got delayed. In the meantime, now where we are, we have a 1.1.1 version of both of these specifications, the I3C, which was not a major change. We updated things, we clarified things, but the big change was the I3C Basic version 1.1.1. We aligned it with the full featured spec, added features, and we're very excited about it. It just released back in June, July timeframe. So what are some of the key features? Why do we believe that I3C is such a great interface? Well, it's a fast and efficient communication channel. Multi-drop two-wire interface with a max clock rate of up to 12.5 megahertz and different voltages supported, 1.2 to 3.3 volts with I3C Basic supporting 1.0 voltage. We also allow the dynamic switching between pull-up, push-pull, high-Z, all great for efficiency. We added line codings, so it's not just a standard data rate anymore. We added high data rates as well. But all of this, we wanted to make sure that it wasn't just a simple bus. We wanted to add advanced functions, things like in-band interrupts, device resets, hot join, error detection, all things that are needed in today's ecosystem. On top of that, we have system management. So there's options for primary and secondary controllers. There's dynamic address assignment, and also DCR, BCR configuration registers that just allow more usability and management for the system designer. And just to emphasize again, there is still backwards compatibility. So for those still using I2C, we added a 50 nanosecond spike filter so that these fast operations can actually be invisible to I2C devices on the same bus. So where are we now? New specifications for 2021. Like I described, we've got our new 1.1.1 versions of specifications. The I3C full version there up at the top, that's got everything in it. Terminology changes, clarifications, incorporations of all the recent features, as well as some modifications for those who have been following I3C. They know about target reset, and that is now included in the specification. Now, the I3C Basic was the big jump from its previous revision 1.0. It synchronized with all the many of the new features. It added all the same clarifications, and it now lines perfectly up with that full version. And then I want to bring your attention here to the table on the right. It really just goes as a quick reference to show you what features are included in the different revisions of the specification that are released at this time. And then there at the bottom, you can see we've also created this I3C host controller interface, which I have plenty more to talk about here in a little bit. From there, we're very proud and we're very excited about our partnerships that we have going on in the industry. JDEC is one of our great partners. We worked with them to create the Serial Presence Detect, or SPD hub, for DDR memory. We've worked with DMTF to create a MCTP, which is a management component transport protocol, and I3C. So we created a binding specification in partnership with DMTF, and we have other partnerships that we're working on. We're working with PCIe, I3C over IEEE 1722. We're working with AFI, working to create a protocol adaptation layer for I3C over AFI. We're also working with ETSI for smart secure platform, and many more. We want to know what other industries, what other partners that we can create, because we truly believe that I3C can go everywhere, right? And also not just the specs, but we've worked very hard to create a great support system and ecosystem for the I3C developers. And through that, we have a lot of supporting documents, things like a conformance test suite. This allows implementers to come together and test on a set of tests that are all defined and agreed upon between the work group. It's great for developers so that they can make sure that their implementation is lining up with expectations. We have our host controller interface, which is a software geared document which helps to software developers in their interfaces with the host controller. There's Linux kernel module. We've got a debug spec for I3C. We've got a disco spec for I3C. We're also working on releasing updated FAQs and application notes, all there just to support implementers. And one of the great things about this is many of these documents came out of feedback. And so the implementers letting us know how we can help them, and we've created a lot of these documents for that. So as I stated, I wanted to jump into our next little topic, our host controller interface. This is a great achievement that we've been able to come up with. So what is the host controller interface and why is it interesting? Well, we created the HCI in order to standardize the interface that platform software uses in accessing I3C target devices and their capabilities. What this does is it really enables the ecosystem for I3C. It allows multiple vendors to come together using various use cases, including IoT, mobile, and data centers, but have a central point that they can all agree on with this standardized interface. And so as you can see in this figure below here, this HCI can be sitting on the system bus right next to the I3C host controller and interfacing right there. And since it's standardized, you don't need to worry of is my system bus going to connect to this I3C host controller? We now have that standardized middle piece. So what are the benefits of this? Well, the ecosystem can now use common software driver to detect, configure, and present I3C to their applications. Common register definitions, common data structures, multiple operating modes to allow flexibility. And what's great is this commonality. It really allows application developers to focus on higher level flows and allowing them to define extended capabilities and really focus on the things that they need to enable to really enable their system as a whole. So little history, where has HCI been? Where is it now? Back in 2018 is when we released the initial HCI version 1.0. There was a lot of support, great specification here. Supported up to 32 devices, was really built around the I3C version 1.0 and basic 1.0 specifications. And so, as you could assume with our upgraded specifications, we needed an updated version of the HCI. So although this 1.0 included all the basics, we came here in 2021, and we've released the version 1.1 back in May, and this is much more aligned with our 1.1.1 specifications. And so we're excited that we're getting everything lined up for implementers to go out there and really put to use. So what did we bring with this new HCI? Support for group addressing, dynamic address assignment with CCCs, CCCs with defining bytes, target reset patterns, all of these great features that will allow your host controller to really utilize I3C to its best ability. And the great thing is we're not done yet. HCI has been able to enable the HCI driver and has been released to open source community. So now we have a open source driver that can be used. This is a huge key component for integrations and other subsystems. But the big thing that is, and here's the thing, this HCI is mostly developed in a software work group, and that software work group really wants to hear about your use case integrations, future requests, improvement ideas. We want to continue developing this, and we are continuing to develop this HCI interface. Version 1.2 is in progress. We're answering requests from different work groups, contributors, implementers, supporting for other dead bus recovery, which is a big support, better support for CSI2, standby modes, scheduled commands, great things for efficiency, as well as support for high data rate flow control. With this, this work group is always aiming to preserve compatibility. That's always been a big part of everything we do is preserving compatibility and backwards compatibility as well. And we are even already working on a version 2.0 generational advancement. However, this is paused in order to get the 1.2 that we were just at out and available to everybody first. But we know in this 2.0 version that we'll be adding support for HDR modes, multi-lane transfers, secondary controller roles, and many other additional changes that we're excited to support. Okay, so finally, with this topic, anytime you're talking about sensors, power efficiency typically comes into the equation, and MIPI I3C Basic is one of the best in enabling power efficient designs. So, as we all know, there are many parameters that affect energy efficiency, from low voltage operation, voltage compatibility, electrical characteristics, managing your idle times, all these pieces. And MIPI and I3C, we've come together to really work together to address these areas. So if we talk about some of these I3C bus electrical features, why is it so efficient? Why do we feel that this is great for the sensors ecosystem? Well, we support low operating voltages. Here you can see we have 3.3 to 1.2 volts. I mentioned earlier I3C Basic actually supports a 1.0 voltage operation as well. On top of that, low bus capacitance and pull-ups of between 1.1 and 2.8 kilo ohms. Okay, so factors affecting energy consumption, right? Current, bus capacitance, pull down current. We shoot to always minimize these. So bus capacitance, short bus length, reducing capacitance on the pads. Pull down current, we minimize pull down time and use push pull whenever possible. All of these hugely important in creating the most efficient bus. Now, when not active, We also support, lower power states. I3C can actually be in 3 different, from pull up to high Z to high keeper. And then the clock, or the SCL line, almost always in push pull, because in I3C there's no clock stretching, which is allowed. That was back in I2C feature, so you might be familiar with it, but in I3C there is no clock stretching. And then also the SDA, we dynamically switch between those different states, and so that we can always keep energy efficiency in mind. So if we wanted to look at a typical bus transaction, you can see here on the left, we've got an SDA, our data line, and our SCL, which is our clock. And that SCL is in a power efficient push-pull mode driven by the controller. So this interface is structured to avoid inefficient pull-up mode, and it's using an HDR, which high data rate, which allows us a great millijoule per bit performance, and a faster bus transaction implies reduced CPU cycles. So these typical bus transactions, very efficient. So if we actually look at energy consumption, the data here and the graph here can really show it all. So with our, I'll explain this graph here real quickly. On the right side of the graph, you can see legacy I2C. I2C was the base of I3C, and we had to make sure we improved on it. So on the far left side of the graph, you see SDR, which is our standard data rate, and the millijoules per megabit there, already doing great to be more efficient than our legacy I2C. Then when we start talking our high data rates, you can see our energy consumption goes down and down. These now, as you can see up there, 1/8 lower than I2C. So we've done a great job in improving energy consumption, because we know in the world of sensors, every bit of energy counts. Another way that we looked to increase efficiency was optimization through bus segmentation. So what you can do through I3C is isolating high activity devices through routing devices. So instead of having to have everything contained on a highly active bus and dealing with all the power there, we can isolate things to create low activity buses and high activity buses, and then those buses can be put into different states, allowing for better processing efficiency as well as much better energy efficiency as well. We wanted to improve our idle time. Informing targets of bus idle conditions facilitates a much better low power management. So if you're familiar with I3C, you will know of things called CCCs, which are common command codes. We use common command codes and created different activity states. And these activity states allow us to enter different bus idle times and allow different entry and re-entry into activity, right? And so by negotiating on your bus, sending different CCCs, you can enter these different activity states and save energy on your system. Another great addition into the I3C world is the in-band interrupts, or IBIs. What these allow, they allow fast and efficient data acquisition and event processing. So instead of having a traditional polling type system, now we allow our targets and our devices, our sensors, to send what we call in-band interrupts, where you can have a sensor say, hey, I have some data, sends an in-band interrupt, and your controller can respond by saying, okay, let me have that data, and it will then send the data asked for. Instead of having to pull all devices as in a traditional I2C bus, now we can be much more direct, much more targeted, and all of this, when we're not having to activate all the different devices, of course, is going to do much better for our power efficiency and energy efficiency. So also, IBI creates an opportunity for efficient data acquisition. So as you can see here, up on our left, we've got our data segment, and how it's done. Additional data is inserted as part of the IBI request. And so now with our new IBIs, there's additional data that can be sent. And by using this additional data, now we can structure our different identifiers. So instead of only saying, "Hey, I've got something," now we can tell them more detail about what there is, and the controller can respond accordingly. If there's a lot of data, if there's a little data, we can adapt and make sure that we're only using as much energy as needed in order to acquire all the data necessary. Hot join. This is power management. So those, you may be familiar with the term hot join. Of course, what this is really, it's adding in a device in an already powered up system. So attaching a device after the bus is configured. But another use case is maybe if you have a device that is slow to power up too. Hot join allows this all to happen. It allows a communication between the primary controller and the unit that is wanting to be added, and allows a graceful entry onto the bus at a different time without causing errors or causing problems on the bus. And so obviously this can also add to, if a device doesn't need to be powered up till a specific time, that can be huge for power savings. So as an example, what you can see here is kind of how how power management is done. The hot join has a similar pattern to our in-band interrupt. It is very much similar as in the target. Once it is permitted to send that hot join request and the bus is ready for it, it basically says, "Hey, I want to join your bus," and the controller responds. Dynamic address assignment occurs, and everything happens so that that device is then brought up and fully working within that bus as well. So, summary, key takeaways. I3C electrical characteristics are very well suited for low power devices, the sensor ecosystem, low power consumption. I3C is not just a bit pipe, but it's a modern bus with very advanced features and great power efficiency through those features, through segmentation, event management, data acquisition, efficiency. On top of that, the hot join feature allows for those power segmented designs, keeping only units active when needed, great for power efficiency. And as more and more I3C controllers and sensors are expected to be in the market, I3C is just a great candidate for next generation designs as well. So hopefully you're finding some interest, you're seeing the value in I3C, and we wanted to let you know how you can get involved. We have an I3C working group that works within the MIPI organization. It is open to all MIPI contributing members. You can also get in contact with us. We love hearing from our implementers, people that are working through and putting this technology into use. There's email. If you're a member of the MIPI organization, you can email us i3c@mipi.org. If you're a non-member, you can email admin@mipi.org and they will get in touch with us. If you have questions, you want to dig in and learn more about I3C, I'd really, besides the specs, look into the supporting documents. We've done some great work to add some explanations and extra stuff to our app notes to help implementers really understand, what the spec means. And of course, we have our website down there at the bottom. Some more information. There's tons of specs. There's tons through MIPI of videos, white papers, a lot of support and a lot of activity around MIPI and I3C, and MIPI has done a great job to forward on those resources to the implementers as well. So that's it for me. Thanks everybody for listening in. I hope you enjoy the rest of Sensors Converge.